Algebra 1, Chapter 2, Section 8, Literal Equations and Dimensional Analysis. So before we get started, let's look at what those things are. So literal equation is an equation that involves several variables. So for instance, x plus y equals 3. Okay? That is our literal equation. And what we'll be doing with it is solving for either x or solving for y. Sometimes it might be something like c equals 2 pi r, okay, and we'd have to solve for the r. It may have, x equals abc, okay, and have a lot of variables in it. That's a literal equation. Our dimensional analysis or our unit analysis, notice it says unit analysis. So analysis just means we're looking at it and we're really inspecting it. Unit is the unit, so centimeters, inches, feet. Dimensional can be like your centimeters squared, your inches squared, your feet squared. So your dimensional analysis, and it can be cube, it can be volume instead of area. It could be singular, as in feet, and measurement in a linear fashion. So dimensional analysis or unit analysis is the process of carrying units throughout a computation. So taking it from the very beginning when you set it up and you still have your feet and your inches in the equation, and then you write them through each time you go to a new line. So of course we're going to start with our 5-minute check here. So state whether the percent of change is a percent of increase or a percent of decrease, round to the nearest whole percent. So our original is 84, our new is 96. So looking at this, we know that it's going to be an increase. It's just a matter of what it's an increase for. So 96 minus 84 over 84, the original. So when we take 96 minus 84, we get 12 divided by 84. We end up with 1400. So it's an increase of 14%. State whether the percent of change is a percent of increase or decrease, and find the percent of change, round to the nearest whole percent. So it was 47 to 18, so we're going to take 47 minus 18 over the original, which is 47. So 47 minus 18 divided by 47 gives us 62% because we round up. So this is a decrease of 62%. What is the discounted price of a tent with a price of $89 and a discount of 15%? So it's a discount, so I'm going to subtract. The easiest way to find 15% is to change that into a decimal and multiply times the original. So that is 1335. That is $75.65 is the new price. There we go. What is the final price of a pair of hiking boots with a price of $78, discounted again means subtract, of 10%. So we're finding 10% of 78 plus a 6% sales tax. So tax means we're adding it on. So it's 0.06 times 78. Got 10% pretty quick. But 6%, 0.06 times 78, is $4.68. So I'm going to say 78 minus $7.80 plus $4.68 gives me $74.88. Okay, so I got a little ahead of myself, and I shouldn't have done 78 here. Let's do 2. There we go. So we should have done 0.06 times what we are actually taxing, which is not the original price. It's this price right here. Sorry for that. So that's that $7.80. So now it's 0.06 times 7.8. So this is not times 7.8. So 78 minus 7.8 gives us $70.20. There we go. So then we take that times 0.06. We get $4.21. So now we take 78 minus 7.8 plus 4.21, and we get $74.41. So to recap this, because I had a few mess ups in this, we start with our original of 78. We subtract our discount, and when we go up to the cash register, our tax is not on the original amount over here. It's on this new amount, this discounted price. So we have to find that first, and then we can plug it in here. On July 1st, a stock sold for $46 per share. And on August 1st, a month later, it sold for $48.30 per share. What was the percent of change in the price of the stock? So we'll take the bigger one minus the smaller one and put it over the original of 46. So we have 48.30 minus 46 divided by 46, and we get 500ths. Move our decimal 2 places, and we get 5%, and 46 to 48 is an increase. So 5% increase, so it should be A. Olivia's cell phone bill last month was $125. This month her bill is $85. What is the percent of change? So again, largest minus the smallest over the original. Let's see, last month was, this month is. So last month was 125. So it's 125 minus 85 divided by 125. Oh no, I did something wrong. So 125 minus 85 divided by 125. There we go, is 32 hundredths. Move my decimal 2 places to the right always. So I get 32%, and it is a decrease. So here's our content standards: rearrange formulas, solve linear equations, and attend to precision. So precision usually means that we are looking at how many decimals we have and what units we're using, how precise the units are. You solved equations with variables on each side before, and now we're going to solve equations for a straight variable. So we're looking for x, we're looking for r. Use formulas to solve real-world problems. We've talked about these words: the literal equation, dimensional analysis, and unit analysis, and how dimensional analysis and unit analysis can be very much the same thing. Here we go, an example. Solve 5b plus 12c equals 9 for b. So we're looking to get that b by itself. The first thing we want to do is we want to say, well, what's with the b? There's a 5 and there's a 12c. Which one do I want to get rid of first? It's that plus and minus. Remember, we're going up PEMDAS, so we get rid of addition and subtraction first. That's why they subtracted 12c from both sides. So now I'm left with 5b on the left. I still want to get b by itself, so I divide by 5. I divide one side of the equal sign by 5. I divide the whole of the other side by 5. But we're not looking for a straight number because we still have a variable on the right side, so we just leave it as we see it. So there we go. Now we want to solve for y. So 2x minus 17y equals 13. So we're solving for y. That means I want to first get any addition and subtraction away. Well, that's going to be the 2x. How do I move the 2x? I do the opposite of a positive 2x, and I subtract 2x. I cannot get an x and a non-x together, so I just bring down my negative 17y equals negative 2x plus 13. Because remember, x and a constant cannot get together. The opposite of multiplying by negative 17 is to divide by negative 17. You do it to one side of the equal sign. Notice I put a fraction bar under everything to show me what's going on. So then this goes away, and I'm left with y equals negative 2x plus 13 over negative 17. You can technically break this up into two fractions. Y is equal to negative 2x over negative 17, and plus that 13 over negative 17, which would come out to be y is equal to 2x over 17, because two negatives make a positive, and minus 13/17. Now, they do not have it written like this. I just want you to see that you can take it a step further. Here we are. That's a horrible bracket. Let's try better. There we go. Either answer in this case is right. You can leave it with the 2x, negative 2x plus 13 over negative 17. If you notice, they don't have that up there. Why? Because they took care of these right here. They took it through, they took the negative, and they divided by a negative here, and they divided by a negative here. So what they wound up doing is they took this answer, and when they took that negative through, they get y equals 2x. So that 2 becomes a positive, just like it did here. And it became a negative on the 13, right there, over 17. That way we don't have a negative on the bottom. That's what they did. So here's another example. Solve 7x minus 2z equals 4 minus xy 4x. So the first thing I see is I have a lot of x's here, which means grouping. We need to get those x's together so that we can take those x's out and do the reverse distributive property. So the first thing I'm going to do is get my x's together, so like terms get together. So I bring that xy over, because then it becomes positive and we have two positive x's. So then we have the x's on the same side. We can get rid of that z that doesn't have an x in it. So we add 2z to both sides, and we're left with 7x plus xy equals 4 plus 2z. Well, since they have x in them both, we can take that x out. And what's left when you take an x away? Well, on this first term, you're left with a 7. And on the second term, you're left with a y. So that's why it's x outside and 7 plus y. If you were to take that x and rainbow it through to the 7 and rainbow it through to the y, you come back with 7x plus xy. So you still have the same thing. You're just starting to rearrange it. After that, we can then divide by everything that we want to get rid of. And because it's in parentheses, we can do that. I would probably have kept the 7 plus y in parentheses as I divided it over, but you don't have to. So we end up with x is equal to 4 plus 2z over 7 plus y. So now we solve 12a plus 3c is equal to 2ab plus 6. So this is 12a plus 3c equals 2ab plus 6. And we're looking for a. So what I see first off is I have some like terms to get together. Not like terms, but like kind of with those a's. I want to get those a's together. But I can't truly get them together because one's an a and one's an ab. But I can get them on the same side of the equal sign. I'm going to just move the 2ab so that it's on the left. My a will be on the left. I'm not lining it up under anything. 12a minus 2ab plus 3c equals 6. That way the c is just kind of over next to the equal sign. My a's are together. Now I'm going to move that c by subtracting 3c from both sides. But again, I'm not lining it up with anything because I can't get a constant and a variable together. So on the left side, I'm left here with 12a minus 2ab. And then on the right side, I have 6 minus 3c. I have that expression. Well, on the left side, I have an a in both of those. So I take the a out. And then I say, what do I have left? If I take that a out, what am I left with? I'm left with a 12 and a minus 2b, and that equals 6 minus 3c. Well, now I still want to get a by itself. The opposite of multiplying a parentheses times an a is to divide by that parentheses. So I'm going to divide by 12 minus 2b, and I'm going to divide by 12 minus 2b. So this goes away. I'm left with that variable of a. And on the right side, I have that whole expression, 6 minus 3c divided by 12 minus 2b. And you can either get rid of the parentheses or keep them. It's just because I moved them, I like having them. You could also put parentheses up here if you wanted to. So our answer, again, was 6 minus 3c and 12 minus 12b. So 6 minus 3b, 12 minus 2b. So A, I'm seeing, yes, where b cannot equal 6. Why are they saying that b cannot equal 6? Well, what happens if b equals 6? Let's try that out and see it. So A would equal 6 minus 3c over 12 minus 2 times 6. So you have 6 minus 3c over 12 minus 12. And what is 12 minus 12? It's 0. So you'd have 6 minus 3c over 0. And guess what can't happen? You can't divide by a 0. So in order to keep this a real answer, b cannot equal 6, because if b equals 6, you get a 0 in the denominator, and we can't have that. So that's why they're saying b cannot equal 6. Next, fuel economy. A car's fuel economy, E, miles per gallon, is given by the formula E equals m over g, where m is the number of miles driven and g is the number of gallons of fuel used. Solve the formula for m. So we find that formula again, we write it down. We want to solve for m. Well, what's with the m is a g. What's the g doing to the m? It's dividing it. How do we get rid of the g? We multiply by g. And we get m equals E times g. So then it asks in part B, if Quanta's car has an average fuel consumption of 30 miles per gallon, and she used 9.5 gallons, how far did she drive? So our average fuel consumption, E, is 30. Our gallons used is 9.5. We multiply to get 285 miles. A car's fuel economy, E, is driven by this formula, where M is the number of miles driven and G is the number of gallons used. Solve the formula for G. Okay, it's using the same formula, but they're not asking the same thing. Our capital E equals M over G. Well, now I want to get M by its, or I want to get G by itself, sorry. This is what I want to get by itself. Well, I can't just move it like I could and get G by itself like I could with the M. I have to do a little more work. It's a two-step problem now. So now I have to move the G first, get rid of the fraction, then get G by itself. So the first thing to do is to get rid of the fraction. I do just like I did before. I multiply by G on both sides. So now I have capital E times G equals M. But we're still looking to get that G by itself. So what's with the G? It's a big E. So what am I doing? You're multiplying. What's the opposite of multiplying? It's to divide. So I divide by E on both sides. And I get G is equal to M divided by E, which is C. And then I go into this. If Quanta drove 1,477 miles and her pickup has an average fuel consumption of 19 miles per gallon, about how many gallons of fuel did she use? So here we have miles is equal to 1,477. And our consumption is 19 miles per gallon. So we put that information in. And so we then divide 1477 divided by 19, and we get 77.7. Okay. One thing you can do to check here is we had miles divided by miles per gallon. So you're checking your units here, unit analysis. So to check that, you would say, well, I have miles divided by a fraction. Well, when you divide by fraction, you then have to multiply by the reciprocal. Okay. Miles go away, and you end up with gallons. So that's actually checking our answer here with what we did, and we don't have to put the numbers back in. We know that because we came out with a gallon, and G is gallons, so it's in gallons, that we have the right answer. So that's another way to check. Chimpanzees. The average weight of a chimpanzee at a zoo is 52 kilograms. If 1 gram is approximately 353/10,000th of an ounce, use dimensional analysis to find the average weight of a chimpanzee in pounds. So hence, 1 pound is equal to 16 ounces. So the weight of a chimpanzee is 52 kilograms. So we multiply that, since we need to get into ounces. And we know we have grams, and we have ounces, we have pounds, and we have ounces. So the first thing we have to do is take kilograms to grams. And then from grams, we can go into ounces. And from ounces, we can go into pounds. So there's a lot going on there. We can get rid of our kilograms, our grams, our ounces, and look at that. We end up in pounds. You're going to be using this whenever you take any of your sciences. So make sure you pay attention to this dimensional analysis or unit analysis. That's why we're doing this, because we need to realize how much fractions and conversions go together and how often we actually use them whenever we are talking about science and math. Okay, so the average weight of a chimpanzee is about 115 pounds. So Janet is walking at 20 laps of a track. I'm going to put 20 laps down here so I know it's important. In a relay race to raise money for cancer research. If each lap is 350 meters, how many miles will Janet walk? So 1 meter is 1.094 yards, and 1 mile is 1,760 yards. So we have to do this using their information that they gave us with the units. Okay, so I'm going to write those out. So 1 meter equals 1.094 yards. And 1 mile equals 1,760 yards. What do they want me to convert? We want to go from meters to miles. Okay. So I need to know how many meters she walks. That's the first thing. Well, she does 20 laps. And each lap, just to make sure, each lap is 350 meters. So a lap equals 350 meters. So I'm going to take 20 times 350. So now I'm converting from laps. We could even go ahead and write this fully out. We have 20 laps. That's where we're starting. Okay. So 1 lap. I'm doing this so that in our dimensional analysis, our units will cross out. 1 lap is equal to 350 meters. Okay. Then I want to find something that I have for meters. Well, I have a conversion here for meters. So 1 meter is equal to 1.094 yards. Still not in miles. What I do know is that 1 mile is equal to 1,760 yards. What can be confusing here is that we have 1 mile on the left. Okay, so you have to start thinking about yards. Yards is what I want to get rid of, so I'm going to put it down here. So 1,760 yards. to 1 mile. Okay, so think about how you can cross things out. So laps crossed out, meters crossed out, yards crossed out. We're left with that mile. So now in my calculator, I can say 20 times 350 times 1.094 is equal to 7,658, and I have miles on top, over 1,760. There's no units on the bottom. We have crossed them out, cross-reduced them. So now I just take that number divided by 1,760, and I get 4.35 miles. Okay, so we've checked our units as we've gone through. We know that we have the correct answer, so it should be about A.